Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In today's video I will solve question number 21 and question number 2 related with the domain and range of the function. But these domain and range of the function will be at BSc level. So let's move toward the 21 number question. It tells that domain of the function y is equal to x plus 3 divided by square root divided by 4 minus square root of x square minus 9. Find the domain of this complex function. So how can we find the domain for this function? Remember, for the given function to be defined, the denominator of this function should not be equal to 0, because the denominator, if we put the denominator equal to 0, it will give us infinity, which is not defined. So in the domain we are dealing with all those real values are with the function is defined. So the denominator should not be equal to 0. In the denominator we have 4 minus square root of x square minus 9. So it should not be equal to 0. Shift this term on the right hand side, it becomes 4 should not be equal to square root of x square minus 9. So now take square on the both sides. So on this side we left with 16 and this side we left with x square minus 9. Shift minus 9 and this side it become x square should not be equal to 16 plus 9. So it become x square should not be equal to 25. So it means that the value of x should not be equal to plus minus 5. Now after this, remember that a square root function cannot take the negative value. It always take the positive value. So over here it become x square minus 9 should be greater than or equal to 0, because if we put negative value or 0 over here, it will not define, it will not give the real value. X square minus 9 can be written as x plus 3 into x minus 3 greater than or equal to 0. Now we will find the solution to this inequality through wavy curve. So over here it gives us 0 by putting negative 3 and it gives us 0 by putting 3, and over here we have negative infinity, over here we have positive infinity. Now in this interval, if I put 0 over here, it will give us minus 9 greater than or equal to 0, which gives negative answer, and in this interval it will give us a positive values. So over here the solution will be minus infinity to minus 3. So if we put 3 over here, it will give us 0, which is actually the valid answer. So we will write a closed interval, and over here open interval union. Over here we will write 3 because closed interval because it can take 3, and we will write an open interval with infinity. We have these two solution and this solution. Over here we have negative 5 to 5. So now we will prove the solution to the argent plane now. Over here we have negative 5 minus infinity minus 3 to infinity. So let's suppose over here I take negative infinity, over here I take positive infinity. After this over here we have negative 5, and after this we have negative 3, and after this over here we have positive 3, and over here we have a 5. And after this, let's suppose I take the value in between this interval. So in between 3 and 5, let's suppose I take 4 over here. So it will give us a valid answer. So it will give us a positive solution. After this, let's suppose I put 6 over here. So by putting 6, it becomes 36 minus 9, which gives us square root. It also gives a valid answer. After this, in this interval minus 3 to 3, let's suppose I put 0 over here. So it becomes square root negative 9, which gives us imaginary number. It means this is not the solution. After this, in this interval, let's suppose I take negative 4. So by putting negative 4 over here, it becomes minus 1 in the numerator. It becomes 4 minus, it will give us square root 7, which is the valid answer. So this interval is also gives a positive value. And in this interval, if I put negative 6, so let's suppose I put a negative 6, so it becomes root 27, and by putting negative 7 over here, it also gives us a valid answer. So my solution will be from negative infinity to negative 5. Over here it can take the 5, we will write a closed interval union minus 5 to minus 3, minus 5 to minus 3. It cannot take negative 3 because it does not give the valid answer. So that's why we will write this bracket. It can take with 3, we will write closed interval because it can take 3. Over here it cannot take 5. So with 5 we will write this bracket open interval, and negative 5 also cannot take 5, we will write an open interval. After this, our solution is from 3 to 5. So union with 3 we will write this bracket, and with 5 we will write this bracket, and union 5 to infinity. So this is actually the required and desired domain. Now move to the next question, question number 2 of exercise 1. Exercise number 1.1, chapter number 1. Thomas Edison 12th edition of BS calculus. It tells that find the range of y is equal to 2 plus x square divided by x square plus 4. Remember this question and the previous question for the domain. These two questions is very important for mid and final term in the university though. So remember, range is actually those output values of the dependent variable for which the function is defined. Over here the dependent variable is y and independent variable is x. So for the range, first we will write the given function in term of y. X is equal to in term of y. So shift 2 on this side, it become y minus 2 is equal to x square divided by x square plus 4. Now shift x square plus 4 on this side, it will multiply with y minus 2. So y minus 2 into x square plus 4 is equal to x square. So y into x square gives us x square y into 4 will give us 4y, minus 2 into x square gives us minus 2x square, minus 2 into 4 will give us minus 8. Shift x square on this side, it becomes negative x square is equal to 0. So x square y will come down as it is, minus 2x square minus x square gives us minus 3x square, and 4y minus 8 will come down as it is equal to 0. From over here, take out x square common, we left with y minus 1 and plus 4y minus 8 will come down as it is. Now comparing with the standard form of the quadratic equation, ax square plus bx plus c is equal to 0. Now the coefficient of x square over here is y minus 1 and over the coefficient of x square is a. So it means that the value of a is y minus 1. And over here bx don't have value in this equation. It means that we will take b is equal to 0. And our c is a constant which plays the role of 4y minus 8. So c will be equal to 4y minus 8. Now remember one thing over here, for this function to be defined, the discriminant should be greater than or equal to 0, which is equal to b square minus 4ac greater than or equal to 0. Now our b is 0, so by putting 0 it will give us 0 and it become minus 4 into a. So a is y minus 1 into c. So c is 4y minus 8 greater than or equal to 0. So it become minus 4 into y minus 1. Now from over here take out 4 common, we left with y minus 2 greater than or equal to 0. Minus 4 into 4 will give us minus 16. Y minus 1 and y minus 2 will come down as it is, which is greater than or equal to 0. Divide both sides of the inequality with negative 16. So on this side we left with y minus 1 and y minus 2, and over here 0 by negative 16 will give us 0, but the inequality will also be reversed because this is negative sign. So it becomes less than or equal to 0. Now we will find the solution of this inequality through the VV curve. So it will be equal to, from over here, if we take out x square common, we left with y minus 3, not y minus 1, y minus 3. So over here the value of a will be y minus 3, y minus 3, y minus 3, y minus 3, and y minus 2. So y minus 3 into y minus 2. So this inequality is 0 at the value of y3 and the value of y2. So over here I take 2, over here I take 3, over here I take positive infinity, over here negative infinity. So in these two interval, if we put let's suppose 2.5 over here, so 2.5 minus 3 will give us minus 0.5, and over 2.5 minus 2 will give us 0.5. So the result will be negative. So in this interval it gives us negative. In this interval, let's suppose I put 3 over here, it will give us positive 0. And in this interval, let's suppose I take 4, it will also give us positive. My inequality is actually less than or equal to 0. It means that it will take negative answer. So the result will be from 2 to 3. So remember the value of y is 2 and 3. So by putting 2 over here, it becomes 2 minus 2 is equal to x square divided by x square plus 4. So 2 minus 2 gives us 0 and multiply x square plus 4 gives us 0. So 0 is equal to x square. So x is equal to 0 and 0. This is the valid answer. So with 2 I will write a closed interval, and let's suppose I put 3 over here, it becomes 3 minus 2 gives us 1. 1 into x square plus 4 is equal to x square. So it becomes 0 is equal to 4. This is not the valid answer. This does not give any meaning. So it means that we will write an open interval over here with a 3. So the required range of this function is from 2 to 3. With 2 we will write open closed interval, and with 3 we will write an open interval. So this is the required and desired answer.